everyone. Thank you for investing your time into this talk about MLOps, essentially, or our journey at Volvo Cars towards MLOps. This is not a talk about autonomous drive, federated learning, edge machine learning, or something along those lines, but I hope this is interesting anyhow. As stated, representing Volvo Cars, I'm driving machine learning engineering and operations. Centrally, we are a sort of enabling unit working horizontally across the company. And our purpose is, in essence, to ensure that we get value out of our ML initiatives, effectivize the processes, and offer the infrastructure, develop the tools that sort of increases the probability of our machine learning systems to make it to production in a robust and streamlined fashion. On top of that, we obviously also do some guidance across the machine learning lifecycle for the silo teams. So let's get started. In 2019, we basically had zero ops. We were very early on in our cloud journey. And in order for you to do data science or machine learning, all you had at your hand was the company laptop. You could also request an on-prem virtual machine with limited amount of compute power for your numerical workloads. And you needed to ask IT to install these tools, and there was zero infrastructure for your machine learning workloads. So what you end up with is a CEO wondering where his AI is about. And obviously that AI is non-existent, has never made it to production. And so therefore you're not getting any value out of it. So that's too bad. And we have these data scientists very eager to provide value, turn data to gold, train their models, and provide value back to the company. So I think not just Volvo Cars, but like the industry as a whole has had a history of a misconception, thinking that the data scientist is fully capable to do whatever is necessary in order to set a AI system up and running, basically. And they thought that data scientists were unicorns, but they are not. And if you're looking at this traditional sort of Venn diagram with like maths and statistics, computer science, and domain knowledge, I think most of them were the spectrum is obviously large and it depends on the person. But in general, as a community, I think the community was more geared towards the math, stats, and domain knowledge, and was kind of lacking in the software engineering perspective. I think right now, as machine learning is coming to a more like applied stage, more mature, we are still, though, in a similar state as software engineering community was back in the 90s. And in general terms, I think it's a bunch of researchers trying to build software. There are edge cases, obviously, but sorry for showing this slide, but I think it's compulsory. And the paper is also great, but you maybe all know that an ML model is not equal to an ML system. So there's a lot of things required in order to get this up and running. Probably somebody else brought this up, so I will not repeat it. So let's just go to the essence of this. A machine learning system is a special case of a general distributed system or very complex software. So why is it complex? It's basically because the inherent uncertainty, which you need to tackle and have control of to the extent possible in a productionized setting. And on top of that, you have a lot of dependencies since you need data to train your models, right? And you might have data scientists that are opting for this high accuracy, great model, and they were just using a lot of features from multiple different sources. And all of these sources is a risk factor for your ML system to fail. So if this underlying source goes down, doesn't get that data, or it sends the wrong data or erroneous data, it will affect your productionized system. So you need to build in more checks, more tests, and monitoring in order to keep track and make sure that your uh, organism is doing what you want it to do. On top of that, where I think, why MLOps is not just general DevOps is the reproducibility aspect here contains like artifacts, like you need to know which data is used to train which model in order for you to have this traceability. So you need to version control your models, version control your data, and other artifacts like hyperparameters and other configurations that you need to keep track of in order to have like this traceability and understand where this comes from. I'm actually surprised that given that like machine learning came out of like academia, and a lot of the practitioners have a background in research. Science, in science, reproducibility is a core concept, and it's a requirement in order for it to like even be called science. But when you come out to the industry, yeah, you're just waving your hands at it and kind of overlook that factor. But it's good that we care about it now. The other aspect is the cross-functional teams, right? So even at Volvo, like to this day, cross-functional teams have been non-existent. In order to set up this ML system, you require vast different types of skill sets, people coming from different like backgrounds and cultures and ways of working, and they need to collaborate from like first stage to last mile in order to like get their ML system up and running in a functional, maintainable fashion. So they need to communicate, speak the same language, collaborate, and so forth. And usually, like, I don't think we're alone here, but at least before you had to like run around the company trying, hey, we need this software engineer to do this, we need this DevOps guy to do that, and these things. And I think they have come to realize that you need these competencies within one singular product team in order to sort of push out machine learning models or systems in a sense. And there are other failure modes, but let's not spend time on that too much. So I want to just skim this through in order to get to the core. Anyways, having the right skills is important. As a data scientist, as a machine learning practitioner, today when we're talking about applied, you need to have some grounding in software engineering. Having decent software engineering skills will make you a much better data scientist. I think in general, this is kind of lacking here. On top of that, when it comes to collaborating, working with data science, machine learning, with these distributed roles coming from different cultures, and even within data scientists, to like have 5 data scientists work on the same problem, for example, because it's complex. I think that sort of practice has been like more whiteboarding discussion, and then each person goes into their cave and there's magically some model pops out of some shitty code somewhere from some data which nobody knows anything about, and nothing like really works together. So what we do have is expert machine learners who don't even know how to use Git. So if you don't know how to use Git and you work with machine learning, it's not rocket science. Spend one day, start incorporate it into your workflow. Everybody else will be happy, and you included. Basic software skills. Due to this fact and working in Jupyter Notebooks, I love Jupyter Notebooks, by the way, but I don't think many of the practitioners have the experience working on complex code bases together or developing more like decent code in essence, because it's basically snippets or functions that are super long. And this is just general experience that, data scientists are not software engineers, but I think we should expect a little bit more software engineering from them. So they have actually been slacking a little bit in that area and not fulfilling their sort of expectations in that part of the disk, essentially. So we had no reproducibility, no scalability or robustness in terms of like, we should have a questionnaire. How many data scientists in this room has ever written a test? like a unit test or a regression test or something like that. Collaboration, minor, but no lineage or nothing like proper in terms of like Git or using tools like GitHub and stuff like that. It's very lacking. Automation wasn't even on the agenda, or CICD for that matter. And adding this CT for continuous training, MLOps concept, none of that. So we wanted to obviously tackle these concerns and make ML development streamlined in order to get our models to production in a robust and manageable fashion. So we needed infrastructure, scalable infrastructure, and we opted for the cloud native stack, having a Kubernetes cluster essentially built with kops, utilizing infrastructure as a service, essentially AWS, but we're quite agnostic here, so we can just set it up on-premise, Azure, or something like that. So huge benefits, scalable, awesome, just go with it. Another aspect which we focused on is templating and reusability, essentially. We try to generalize things into components which can be utilized across teams and can be tested better and have better like quality. And templating in terms of like we have a template repository which gives a good starting position when working on a machine learning project, so that you have good structure of your code. In addition to that, you get your CICD sort of inherited. You have linting, you have coverage tests, things set up with PyTest, which most of the data scientists haven't touched, at least. So getting a lot of that for free just saves a lot of time, and the sort of what we're hoping for is a better output, essentially something of value that you can use and maintain over time. So that was one thing we'll show you later how that goes in here. I mentioned like automation and CI/CD, so we wanted to sort of, obviously, you want to glue your infrastructure, make it like really tight with your Git flow or your version control system. So whatever happens there should basically your master branch should be reflected on towards your like production system, and make sure that if you're doing a merge, you're building, pushing, deploying the new versions and these things. So we'll dive deeper into how we're going about these things. So on top of that, we do expect like some software basics in order to get going. So there is a bit of a learning curve for many, but I mean, these aspects are not rocket science. So what they do is rocket science, and these are just simple things. It just takes some practice to get it going. And so basically you need to be able to understand how to work properly with Git and have a review process in order for you to like have automation built on top of that and make sure things are functional. So just basics. We try to evangelize good principles in terms of the design of an ML system, first mile, last mile, guide them along the process and the life cycle of your project, and like where to start, what things to think about when you are aiming for production, which you basically always should. And so talking a little bit more about the glue here and mentioning the tools here, I mentioned cloud native stack and Kubernetes, and there's this service called Kubeflow, which is starting to become the de facto standard. Obviously, there's competitors in this, but it's an open source tool and a de facto standard to sort of manage your machine learning workloads on a Kubernetes environment. What it essentially does, it offers a unified interface for machine learning practitioners, which simplifies and abstracts away some of the complexities of Kubernetes and the cloud native world, but still provides that sort of power to the ML practitioners and the systems in itself, which is awesome. And this is open source, so we can obviously extend and configure according to our liking. And it sort of ties in very nicely, like if you wanted to, you can use Kubeflow to orchestrate SageMaker or Databricks or something like that. So it's quite agnostic. We're using it as a like central component. On top of that, we have started working with Tekton, which is a CICD service running natively on Kubernetes. So it gives you the option to sort of trigger run pipelines, tasks, and these things. There is a DSL for Tekton as well to just be the underlying workhorse for your MO pipelines. But right now it's still Argo, but we're probably changing it to Tekton since the CI/CD and the automations around it is utilizing Tekton. That is what is gluing together our events on GitHub with our infrastructure. So yeah, it's a good match, and we'll show a demo later on. Yeah, automation, yeah, automation. It's, yeah, I think it's a good metric for the maturity of your ML process or project in general. Obviously, there are other aspects that ties back into this. You need to be mature in the context of data, and your models development and these things needs to also be in place. But yeah, automation is cool and fun and streamlines things. So looking like a little bit high level on the design, I tried to sort of abstract what is basically going on and what we try to achieve. Is basically starting from a repository using the sort of Git flow or GitHub flow. You would branch out from master if you want to introduce a new feature. Let's say you want to develop a challenger model, or you want to add a regression test, or you want to, add a component to your pipeline that runs, I don't know, maybe you want to do some additional quality checks for your data with, I don't know, great expectations. And yeah, essentially you branch out, you do your development, you do your commits and stuff like that. On top of these, we have like coverage tests, we have linting and these sort of things that happens on your commits. We have slash commands on GitHub, which basically communicates with the infrastructure or the pipeline API so that you can trigger runs of your pipeline. And obviously the pipelines, the components, since this is cloud native, the pipeline engine is essentially just describing the sequence of pods which should run after each other with some conditionals or whatnot. So each sort of pod needs to have like a container. So you're building these images, you're uploading it into our image registry. We're using Harbor, for example. So all of this is sort of abstracted away from the data scientist, but underneath the hood, we're sort of tying together using Tekton to sort of create the webhook on GitHub, map that to an event listener, and then have these triggers to sort of trigger the builds of these components and a compilation of these pipelines and uploading them to the platform essentially. And then the slash commands, which is a fun extra thing. So that can obviously be extended quite a bit. So that is what we're trying to build in and make them follow this sort of Git procedure to sort of review the code, review the analysis, utilize GitHub as this community sort of platform to discuss some version control, have threads around your work to get that lineage. And it also makes it super much easier for like a new colleague to sort of jump into the project and understand what has been going on. So yeah, looking at this picture a bit, you can just trigger and orchestrate your experiments, feed in some params through your pipelines, and then you merge this to master, and a reflection of your branches, your commits will be uploaded to the infrastructure. And that could be like an ML pipeline that is ingesting some data, doing some cleaning, doing some model training, serializing your model, uploading it to some object store, utilizing this in an inference service so that you can provide your predictions, or maybe you have this continuous training system based on like the monitoring and logging. We're using the standard sort of elk stack and then Prometheus and Grafana to sort of log what's happening in a productionized environment. So you could have custom metrics and set like thresholds when your model is degrading or there's some skew going on, so model drift of sorts. And yeah, so that's what we're using to tackle and understand what is basically going on. And ideally, these ML systems have at least like unit tests and some other tests, and we'll maybe talk quickly about like ML specific tests like behavioral tests later on. But I could see like you have a ML system running in production, you're noticing some weird behavior on particular type of examples that are being fed into your inference service. So what would you do? You would go and do some analysis. Hey, why is it behaving like this? It shouldn't, right? So what you want to do is, as an ML team responsible for maintaining this, you would go ahead and try to add a behavioral test or some sort of a regression test to ensure that that type of regression will not happen when you're making choices on further models. So your next model would need to pass that test so you know that it behaves as you want on those particular examples. And the story goes on, you continue to iterate, and yeah, that's it. So let's go back to the slides here. So maybe I went through this, so I'm just going to say this. You would use the template. They will commit a profile.yaml, which describes basically who has access to which profile. It will create the webhook, the event listener. On top of that, create the application workspace, a namespace or a profile, depending on like which language you're talking. And with the added contributors, and we create a Minio sandbox, which is basically an object store for the project, and then we link the project-specific CI, or basically the general CI, which everybody needs, and then this can be extended if you have more complex use cases. But talking about the reproducibility aspects here, we're using a tool called DVC, which is version control for our data or our artifacts in general, but it doesn't really version control them. But what it does, it provides you with the capability of having a pointer towards your artifacts in your GitHub sort of history or GitHub repository in a sense. So you will have a particular hash for a particular version of a data or a model as a sort of pointer towards it in an object store of choice here. So we're using basically Minio and S3 and Azure Blob. It depends on which cloud. So we're in a multi-cloud environment at Volvo. Just quickly mentioning this, what you want to achieve is essentially as quickly as possible, get a good, nice feedback loop. Don't focus too much on getting the most complex model up and running, but you want to have the components in place for you to make a good evaluation of, should I pick this model as opposed to the other one? So maybe just setting up the baseline and having the right sort of evaluation mechanism, being able to get the live data or like the ground truth tracked, and you have good metrics around this. So use like a lot of metrics, and yeah, it's just important to get this sort of in place in order for you to iteratively improve on your ML system. So I guess we have come to the time of the demo. So what I was planning to show you is the structure of the repository and some of the CI things, and just a high-level overview of the platform and some of the capabilities. This is a repository that has been created based off the template repository. So all of this has been inherited from that repository as kind of boilerplate. On top of that, a user has added this profile YAML, which I added earlier, which I told you about earlier. So here you just set an owner, the admins and contributors, which basically ends up as a reflection on the platform in itself. So just quickly going about this, we have a data folder. We have a notebooks folder here. Maybe worth mentioning that you can see that it's a PY file, so we make use of Jupytext. So we don't really commit the IPyNB file because the diff is kind of nasty. It's a JSON file, and then you can pipe it to black and do some other nice things there. So on top of that, we have this source folder. So we try to push for refactoring your functions to source and using these cell magics to auto reload these functions when you're importing them in your notebook. So instead of copy pasting around different versions of your functions in notebooks or like between your colleagues, it's good to have them in a basically module so that you can add some tests to them and have more assurance that these are functioning in a similar fashion for both of you, and so you don't basically repeat yourselves. We have a couple of source modules here. The dummy is supposed to basically be removed, but we just added an add one function. Added some tests here just to basically show the users a suggested structure for this. So, based on that, then I think what's interesting is workflows here. So this is the orchestrated experiments for the pipeline. So you have your pipeline definitions at root, and what the automation will do is basically compile all of the pipelines listed here and upload them with nice sort of version and commits, making sure that there's a good reflection of the pipelines and their particular versions on the platform itself. I'll show you later. But yeah, maybe just quickly skim through. This is, in terms of the pipeline, it's very uninteresting, but yeah. Then you have this components folder where you're supposed to like add all of your components. Each component is basically requires a Docker file for it to be sort of define that place, and a component YAML, and basically the source code that kind of defines this component. So what you do in this case, you're just importing this random add one function and utilizing it in your workflow. Yeah, and yeah, so what the automation does is basically it reads off this Docker Compose file and builds and pushes and tags these sort of images correctly so that they are made available for the pipelines on the platform in itself so that they can actually run. So yeah, maybe we can switch over to the sort of platform here. This is, yeah, so you have this models UI so you can actually track some metrics and stuff like that. But what I was planning to basically show you is what you can see here is essentially these pipelines then that has been uploaded so the user doesn't have to do anything. And this is the example pipeline from this particular demo repository, so the repository name. What you can see here, there are a couple of PRs that have not been merged yet. So you have the PR number and then the particular commit. And then you have the main with the latest commit here. So these are all like versions of the pipeline. Furthermore, you can see here that there's an iris pipeline here. And this iris pipeline is coming from a PR that hasn't really been merged yet to the platform. So what we do have is essentially, let's have a look at these this pull request. So here, a colleague of mine has submitted a PR. You can see here that you're getting basically checking coverage, bumping the image tags, cloning and building the images and uploading them to the pipeline, and a lot of linting and stuff. So this hasn't been passed, so we basically should not merge this one. And what you have here is like, okay, so we added a train iris component. to the list of components. You added the Docker file, these things, and you have the training function. And then you have the Iris pipeline here, which you saw was uploaded. So here's fetching from reusable components, a KF serving deployer, and basically specifying the operations that should run and in which order. And that is what has been uploaded here, right? So you can just utilize these ones and try to do a run. As an option, then we do have this capability of basically specifying, utilizing the chatbot command, a run pipeline where you specify the pipeline, and then you can send in some optional parameters here, and you'll get your status and run here back. So we can look at this one and see what happened. Yeah, so, oh my God, it failed. But that's good to see. So here you can see an example run of this pipeline, which is being sent to an experiment in this namespace. You'll get some nice outputs. You can send out some visualizations and stuff like that. You can look at logs. In this case, it was taken from cache because this has already been ran someplace, so it's not doing any unnecessary work. And let's see why this kind of failed here. You can see the logs here. So it's, there's some reason for failure here that one can go through and decide. It's not really the context here, but essentially you can just trigger that pipeline from there, get the results, and it's specifying the right sort of version here with respect to, now I kind of opened it, but this is the actual PR number 7, and then the commits there. And you can see that it was uploaded to this sort of these project pipeline demo. You can get the status and you can extract some metrics. And if there were more of these ones here, you could compare the runs with each other. So this is pretty neat. Other than that, you have this way of utilizing notebook servers, and these are essentially pods that you spin up, and you can, not showing too much, but we have a couple of different image versions here for doing different things. And you can use VS Code and RStudio, utilize GPU, specify tolerations, and add configurations that you think are necessary for your workloads. I guess that's about it in the context of time. I'm going to leave it there. There's a lot of more to show, but thank you. Yeah. Okay, so we have a little bit of a roadmap, obviously. So we're not 100% happy with DVC. It's not like very efficient with Minio, for example. And it's just not the best. I'm hoping that there is something better out there. So please contact me if you have any of those experiences with something. But not really there yet. Another thing is, since we have this chatbot, you saw this run pipeline / command. We're working on the launch notebook so that, during the review procedure, a person can open an interactive checkout of that particular PR and have that server started for them. And obviously we want to provide more feedback back to GitHub for the particular runs. And there's just endless possibilities in this area. So we will definitely do more in order to tie GitHub with our infrastructure even stronger together. We are in need of better AD integration. So our AD at Volvo Cars is using Azure AD. So right now, that mapping is not 100% there with our Kubernetes cluster. It's mapping to GitHub, and thus we need to have these profiles. We cannot really have this one-to-one mapping and these things. So that step of having this profile.yaml could be vastly improved. we want to have tighter integration with our internal data stores. And yes, we have deployed Feast, but we don't have, like the example, we haven't evaluated much, but we see a good place for that in our infrastructure. So basically, it's you seeing features as first-class citizens. You can host them streaming fashion or batch fashion. And this way you can reuse features across models and projects. So I think that it's an interesting project, but we just haven't had time to fully incorporate it yet. So coming back to these pillars of MLOps, we have tackled reproducibility with the aid of DVC, snapshotting the infrastructure in general, making sure we have a good lineage, and tagging with the sort of commit hashes and these things. So this aids with that, obviously. Scalability, cloud native, Kubernetes, highly scalable, distributed system, distributed training, pretty awesome, pretty great. I've just showed you a very, very limited piece of what you can actually do in this context. Collaboration, yeah. Data scientists, machine learning practitioners, please learn Git, should be standard. And utilizing the sort of community features, we do have some in-house knowledge base, which we host, kind of like documentation based on make docs, and being able to pull in documentation from individual projects so that we have transparency, so that people can learn from each other, building up a community thing, and trying to sort of map back tools. So obviously the output from this data science team that is working in a cloud native world is essentially puking out a lot of YAMLs, which are readable by the DevOps team. And if they're working in the software fashion, then maybe more of the ML engineers and these ones, they could just streamline how they work together. I showed you some of the automations with Tecton here being the tick mark. Obviously, this is just a continuous process of adding more and more things until you can basically go berserk here. But the standard components are there in order to sort of effectivize the workflow for our internal teams. Now, robustness, I gave this one a little bit of like a red circle because we are not really there yet, but we're working on it. So when I talk about robustness, I essentially talk about treating our machine learning like our cars. So we need to test them more. And I think the ML community hasn't really fully adopted the concept of testing in the concept of ML. And given that these systems are even more complicated and less deterministic, you actually require more tests. And I hope that can be improved in many cases. So what we want to do is basically, yeah, like all our code, we need to test our models in different ways. So yeah, I kind of like this. When you're evaluating you have evaluation metrics which you're looking at in order to state is this model better than the other, but in essence, there are summary statistics. So it gives you a pretty two-dimensional view of how your model actually behaves. So what you would want to do is do more of behavioral tests, and in order to test ML is quite related to just being able to slice and dice your data properly to provide particular examples or subsets of your data to see how your particular model or model behaves on these particular examples, so that you could write tests for the type of behavior and gradually have a lot of metrics, have these behavioral tests so that you can build up a three-dimensional view of your model, right? So you can start making better comparisons. So there are intricacies into each and individual algorithm. And I hope this can be more improved. So yeah, just stating here what model evaluation covers and then what model testing would involve. And so the talk is not about testing here, but I'm just mentioning these failure modes and behavioral regression coming to this then. So what you want to have is basically a red team maintaining or making sure that your machine learning system is doing what it's supposed to do in a productionized environment, and making basically taking care of issues, making sure yeah, because these can be risk factors, right? So let's assume you're using some machine learning that is related to the braking in the cars. uh, Maybe you need to have rigorous testing on this, because it can be a matter of life and death in that scenario, but it can also be ethical aspects. And if you have mature MLOps, that sort of process in place, this red team is just something that is streamlined and agile. But being able to, like, having this strong review, stress testing of your systems, I think is relevant, and it should consist of also, this is a cross-functional team of data scientists, ML engineers that focuses on trying to basically break the break your system. Yeah. Anyways, what is MLOps? MLOps is a practice. It's not a tool or a platform, even though I've shown you some of these tools, but these are tools that supports the practice, right? But everything cannot be done by the tool. So you need to have some culture in place. So if you're an applied ML team, you have to have certain guidelines in the back of your head as a data scientist or anyone responsible of this designing this ML system, when because some of the choices that you're making will affect the reliability or even the probability of this ever making it to a productionized environment. So these are cultural aspects. So I do I highly suggest that if you're working with applied ML, everybody in that team should have some sort of notion of what MLOps is and some guidelines in place. So this is an example of the reward of deletion of features. I touched upon that earlier, that it's a dependency potentially, and it's a risk. So you should reduce that, and complexity, these things. So just going on to these things, this is a cultural aspect. I maybe touched upon this also, but aim for a neutral first launch. So don't go with the crazy best model. Maybe you just set up all of the components, set the feedback loop in place, get the baseline up and running, so you have something to benchmark against. You have proper metrics in place so that you can make proper decisions of, is this model better than the other one? And you will expect throwing away like at least the 5 first before you reach any type of goodness, like in terms of the actual business objective that this system was built for in the first place. So what is the objective of MLOps? And basically the objective of our team as well is to shorten the development cycles and increase the development velocity in order to reduce friction and delays in the AI value stream. So kind of businessy, but I think it sort of encapsulates the thing quite well. So jumping to the references and links, you can look this up later. I'll be sharing the slides. Nice reads. Now, have you ever deployed a model to production, collaborated on a large code base, written a unit test or a regression test? In that case, we are hiring. You can basically just scan this QR code. We'll be there at the job fair to answer some questions. And you can also send me an email or whatnot. So there's some contact information. And let's just make ML great again. Q&A. Thank you for listening. Hope it wasn't boring. And yeah.